We are living in one of the most exciting periods in human history. For thousands of years, humans looked at the night sky with curiosity, wondering what lies beyond the stars. Today, astrophysics has entered a powerful new era. With advanced space telescopes, gravitational wave detectors, and artificial intelligence, scientists are uncovering secrets of the universe that were once thought impossible to understand. Every year, new discoveries are reshaping what we know about space, time, and reality itself. The universe is no longer silent. It is speaking, and astrophysics is teaching us how to listen. One of the most shocking discoveries in modern astrophysics is the realization that the universe contains far more galaxies than we once believed. Earlier estimates suggested hundreds of billions of galaxies, but newer deep space observations reveal that the number could reach into the trillions. Many of these galaxies are extremely faint, distant, and ancient, formed shortly after the Big Bang. These discoveries help scientists understand how galaxies grow, merge, and evolve over billions of years, proving that the universe is far more crowded and complex than previously imagined. Black holes were once thought to be cosmic monsters that only consume everything around them. However, new astrophysics research has completely changed this idea. Scientists now believe black holes play a key role in shaping galaxies. Supermassive black holes at the centers of galaxies control star formation, influence cosmic gas flows, and even help galaxies survive. The discovery of gravitational waves, ripples in space-time caused by black hole collisions, has opened a new way of observing the universe. One of the biggest unsolved problems in astrophysics is dark matter. We cannot see it, touch it, or directly detect it. Yet it makes up most of the universe's mass. Experiments and space missions suggest that dark matter forms invisible structures. Galaxies will fly away. Astrophysicists are now using advanced simulations and observations to map dark matter's presence across the universe, bringing us closer to understanding this mysterious cosmic substance. Even more mysterious than dark matter is dark energy, a force that is causing the universe to expand faster and faster. This discovery shocked scientists because gravity should slow expansion, not speed it up. New astrophysics research shows that dark energy dominates the universe and controls its future. If it continues to grow stronger, the universe may end in a cold, lonely expansion. Understanding dark energy could completely rewrite the laws of physics as we know them. Astrophysics has also transformed our understanding of planets beyond our solar system. Thousands of exoplanets have been discovered, many of them Earth-like. Scientists are now studying their atmospheres, temperatures, and chemical signatures. Recent discoveries suggest that water vapor, organic molecules, and even possible signs of life may exist on distant worlds. This raises one of the most powerful questions in science. Are we alone in the universe, or is life common across the cosmos? Neutron stars are some of the densest objects in the universe, and recent discoveries have revealed just how extreme they are. When two neutron stars collide, they produce powerful explosions and heavy elements like gold and platinum. These events help explain where many elements on Earth come from. Astrophysicists now use these cosmic collisions to test physics under conditions that cannot be recreated on Earth, giving us clues about the true nature of matter and energy. New astrophysics discoveries are forcing scientists to rethink time and space themselves. Observations show that space-time can stretch, bend, and ripple, quantum physics and cosmology are slowly coming together, suggesting that reality may be far stranger than we imagine. Some theories propose multiple universes, hidden dimensions, or time behaving differently under extreme conditions. While these ideas sound like science fiction, they are now serious scientific discussions backed by observation and mathematics. New astrophysics discoveries are forcing scientists to rethink time and space themselves. Observations show that space-time can stretch, bend, and ripple. Quantum physics and cosmology are slowly coming together, suggesting that reality may be far stranger than we imagine. Some theories propose multiple universes, hidden dimensions, or time behaving differently under extreme conditions. While these ideas sound like science fiction, they are now serious scientific discussions backed by observation and mathematics. The most exciting part is that we are only at the beginning. Future missions will search for life, explore black holes in detail, and unlock the secrets of dark energy. Every discovery leads to new questions, pushing humanity closer to understanding its place in the universe. Astrophysics is not just about stars and galaxies. It is about who we are, where we came from, and what our cosmic future may be. The universe is vast, mysterious, and alive with discovery.